All right, welcome back to Calculus 2. We are going to try to integrate x times the inverse tangent of x dx. This problem screams at you, use integration by parts. I don't know what the integral of inverse tangent is. I know what the derivative is, but I don't know what the integral is. So we don't know that one. We're going to have to do it by parts in order to force our hand here. So we're going to say let u equals, and what's the thing we know a derivative of is inverse tangent, of course. So we could set that equal to inverse tangent. My du is equal to 1 over 1 plus x squared dx. My dv, what's left, is x dx. So v must be 1 half x squared. So here we go. We have our flick and swish here. So we have our uv minus v du. So we have 1 half x squared tangent inverse of x minus the integral of, I'm going to pull the 1 half out in front here. So we have x squared over, I'm going to change this to x squared plus 1. Okay? Just you'll see why in a minute here. So rather than dealing with polynomial division, because technically we'd have to do that in order to get our partial fractions in order to work through this thing. And I don't really want to integrate this piece anyway, because I get an x squared on the top and x squared on the bottom. I'm not going to get a du. It's going to be messy if I just try to do it with parts. So here's what I'm going to do. I'm going to add 0. So what we're going to do is we're going to add and subtract 1. Okay, and then we'll break this thing apart. There's a dx here. Okay, so here's what we have. We have a 1 half x squared. Let's go back up to here. We have 1 half x squared tangent inverse of x, okay, minus 1 half, right, here we go. And here we're going to break this apart. So we have integral of x squared plus 1 over x squared plus 1 minus 1 over x squared plus 1. We're allowed to take apart numerators like this. We're not changing the denominator times our dx. Now look what happens. Our x squared plus 1 over x squared plus 1, that cancels. We're just left with 1 here. So one more line down, we have 1 half x squared tangent inverse of x, okay, minus 1 half integral of 1 minus 1 over x squared plus 1, and then all of this is times dx, okay? That's a much easier integral to work with. So here we have 1 half x squared tangent inverse of x minus 1 half. And now we have to integrate 1. That's a physics integral. We could do that one. Minus. And now we have to integrate 1 over x squared plus 1. Knowing our integration facts, that is going to be 1 half from this 1 half out here. Inverse tangent of x. Don't forget your plus c, and that's what we have here. Okay. We could do a couple of things if we really wanted to. We could go ahead and say this is going to be a 2, parentheses. How about x squared? Oh, no, I want 1 half. I pulled out. I didn't pull up 2. I pulled it out 1 half. So we'll put out 1 half. So I have a 1 half x squared minus 1 times the inverse tangent of x. So if I multiply this back in, I get back my 1 half x squared tangent inverse. I get my minus 1 half tangent inverse. Okay, minus 1 half x. There's no tangent inverse on that one, plus c. Now we could go ahead and say that would be a nice answer. So we'll stop there. So with this one, I think the clever thing that I showed you guys was instead of trying to wrestle with this x squared over 1 plus x squared and deal with that, we're gonna add 0, right? Because we can add 0 and multiply by 1. So the 0 we're going to be adding by, we're just going to add subtract 1 over x squared plus 1, because that makes it an easier integral to work with. Okay, so that's how you do that kind of a problem. Thank you very much for watching. I'll see you in the next video. Until then, take care.